Welcome to solverfy.
In this problem, we have a car moving with a constant velocity of 35 feet per second along some path defined by r of theta equals 200 over theta feet. And we want to find the radial and transverse parts of the velocity when the angle that the car forms is pi over 3 radians. So I've gone ahead and written out the formula for this. This is the radial component of the velocity, so it's just dr dt, and the transverse component is r times d theta dt. If you look at this, uh, we know what v is since it's a constant. We know what r of theta is, but we don't know d theta dt and we don't know dr dt. Dr dt, which we also write as r dot, we can write as dr d theta times d theta dt and cancel out the thetas there. So we can really just write this as dr d theta times theta dot. And I'll go ahead and rewrite dr d theta as r prime just for this problem. If we plug that in, we have that v, or this should be a vector, but the magnitude of this vector, v squared, the magnitude squared of the vector, will form a right triangle with the two components of the vector. So this will be equal to r dot squared plus r squared theta dot squared, which we can substitute in here as r prime squared theta dot squared plus r squared theta dot squared. And we can factor that theta dot out, theta dot squared, r dime squared plus r squared, to find that theta dot is just equal to v over square root of r prime squared plus r squared. So we can go ahead and plug in. So r of theta is 200 over theta. So r prime of theta is 200 over theta squared, and pull out a minus sign there. We want to find this when theta is pi over 3. So r of pi over 3 is just going to be 200 over pi over 3, which is just 200 times 3 over pi, which is just 600 over pi. And r prime of pi over 3 is similarly going to be this denominator squared and a negative. So that's going to give us 200 times 3 squared, which is 1800. So 1800, because it's 2 times 9 times 100 over pi squared. So we can go ahead and plug in v also, which is 35 feet per second. So that's going to be 35 theta dot is 35 over square root of 1800 over pi squared plus 600 over pi squared. And we'll plug this into a calculator real quick. 35 divided by quantity square root of quantity 1800 divided by pi squared plus quantity 600 divided by pi squared gives us radians per second. And if we wanted to verify these units, we could see that this will be feet on the bottom. This is feet per second on the top. So that'll just give us inverse seconds, and radians are dimensionless, so we can put them in there. So now that we have everything we need, we can start plugging things in. So UR, the radial component, as we discussed, is r prime times theta dot. So r prime times theta dot, which is just 1800 over pi squared times 0.058. So 1800 divided by pi squared times 0.058 is about 10.6 feet per second. And the transverse component, theta, is just r times theta dot, where r was 600 over pi. So that's 600 over pi times 0.058, which is 11.07. Or I guess we can shorten that to 11.1 feet per second. And for the sign on these, r prime is negative, so this should be a negative. These were squared, so we don't care about that, but this will still be a negative, and this will also be negative. And that's our solution. So that is our solution.